Now, let me introduce this to you. MS is short for mean square, and mean square just means variance. I know it's frustrating. I get that. But the ANOVA people didn't like the word variance, I guess, and they had to call it MS, mean square. I just need you to know that MS is variance. So when I say MS between group, MS within group, that's the same thing as saying variance between the groups, variance within the groups. And of course, the variance between is looking at the variability between the means. And so it's treatment effects plus individual differences plus error. MS within the groups, that's variance within the groups, and that looks at the variability of the scores. First, separately for each group, and then we get an average or pooled variance. All right, so let's see. If the treatment effect is very close to 0 here, and this number, whatever it is here, cancels out this number here, and you're left with a number very close to 1, right? So if you divide this by this, you're going to get a little less than 1, a little more than 1, etc. If that's the case, then what it's telling you is that the means, right, MS between group, variability between the means vary about the same extent as the scores do within a group. So it means that the differences among the means, and that's measured through variability, because if there were no differences among your means, variability would be 0. If there's a huge difference between the means, then your variability between them would be a very large number. All right. So this is how analyzing variance tells us something about the means. All right. And it's again, if all your means are close in value, then variance between group is going to be very small. And if the means are all very, very different from each other, then this number here is going to be a lot larger. All right. Okay, going back to this though, if your F value is close to 1, that must mean that the means varied about as much as the individual scores, which means there's no treatment effect. There's nothing spectacular going on. Null, not a nothing. Okay? However, as your F value is bigger and bigger, it means that this number here is either getting bigger and bigger, which means that your X bars are getting more and more different from each other, right? The larger your differences between sample means, the bigger this number gets. They become more and more variable. That's one way you can increase F. But another way is to say, well, maybe F is getting bigger because this is getting smaller, right? Your error term is getting smaller. Or maybe it's a bit of both. Maybe this is getting really, really big and this is getting really, really small all at the same time, and that's making F larger. All right. And of course, if F gets big enough to get into the rejection zone, then it's significant. And we can say there is a treatment effect. All right. For sure, though, for your F to be significant, your MS between, so the between group variability has to be bigger than the within group variability. All right. And it needs to be sufficiently larger than within in order for you to get into a rejection zone. And recall that, that's a good reminder. This here, okay, can be very large and make F large. This will always have to be bigger than this, but maybe F is getting bigger because this is getting smaller very quickly. All right. Either way, this F value has to get bigger and bigger. It has to get over that critical value in order to be significant, in order to fall into a rejection zone.